Hello, my name is Evelyn Ramirez. I'm in General Physics 1. My group is Group 5. My teammates are Angel Macario, Abigail Macier, Clarissa Cerros, and this is our lab report number 8. So the objective for today's lab, we will observe how momentum and the kinetic energy are affected by a collision. We will call a collision elastic when colliding objects rebound without lasting deformation or generating heat. We will call a collision inelastic only when the colliding objects deform, produce heat, or stay stuck after the collision. For the procedure, we first began the lab by gathering the materials and setting up the equipment. We weighted both carts and decided that we were going to use a velocity graph to set on capstone. We set up the magnets in the carts and placed them on the track. We had to change the sign in one of the carts in order to see the velocities with the same sign from the table. As we ran the experiment and the graphs were ready in capstone, we labeled our graphics and chose 2 different points from both of the velocities made from the carts and used those points to get our data. We had to run several tries in order to get the perfect elastic and elastic collision from both of the carts while also adding similar to different masses. After having the data needed, we calculated the percent difference between the total momentum before and after the collision, as well as the kinetic energy for the 4 cases we needed for this experiment. So for the 4 cases, we had to do an elastic collision with the same masses, another elastic collision with different masses, and an elastic collision with the same masses, and the last one was an elastic collision with different masses. For the equations used, the momentum equation is momentum equals mass times velocity, and the kinetic energy equation is kinetic energy equals 1/2 mass times velocity squared.
For this lab, the materials we used were the program capstone, the passport motion sensor, 2 different carts, magnets for those carts to measure kinetic energy, and a strip for those carts to move on.
The video for that, it didn't work. It don't work. Oh, where are the cards? We don't have cards. And
these are the Lab A results. We have our table for the elastic collision. We couldn't do the other one because of the Velcro attachment. But first we have P, which is our momentum, which is mass times velocity. And then our KE is our kinetic energy, which is 1/2 times the mass times velocity squared. So we calculated for our before. There was a total of -61 for our momentum, and our kinetic energy is at 76.62. And then for the after, we calculated a -52.25 for the momentum and 36.68 for our kinetic energy. And then once we added a different weight, we got 32.5 for our momentum, which was for before, and then 119.84 for the kinetic energy. And for after the collision, we calculated a 37.5 momentum and a 97.28 kinetic energy. For our percent difference, we have here that for the same weight, the percent difference for the momentum was 15.45%, and for the kinetic energy it was 70.5%. For the different weight for a percent difference, we calculated our momentum to be negative 14.29% and our kinetic energy to be 20.88%. And this was the weight for the same weight. And this was the graph for the different weight. And that was everything for lab 8.
During this lab, we faced several challenges that affected how we completed the experiment. First, the cards that we were supposed to use didn't work properly, so we had to share equipment with another group. Discuss some delays and discussions to make it harder to collect our data on time. We also noticed that the program we used to record the motion was defective, so we had to correct that as well. It wasn't reading the data accurately, and we had to restart it in multiple times. Another big challenge was the mathematical equations that were complex and took a long time to solve, especially when checking our results for accuracy. Finally, the push and read goals for the cards of the other group didn't work as expected. So we couldn't rely on the automatic readings. Instead of we had to manually measure and calculate the force we applied. It was especially difficult because we were under pressure of the other team looking at us while we do the experiment, and it was hard for us to push the cars in the same direction with the same force and everything. It was complicated because of that. Even with these difficulties, we managed to finish the lab by collaborating and double checking our measurements carefully.
Thank you, YouTube. Your shit didn't work.